Welcome to Challenging GCSE Maths Questions with Mr. Wesley. Every day, we take on one mind-boggling GCSE maths question designed to stretch your brain and push your skills to the next level. Mr. Wesley will break it down step by step so you can confidently ace those tricky final questions on your exam. Grab your notebook, your pen, and your calculator. Let's get solving. Oh, and before we dive in, make sure you hit that like button and subscribe. If you have any challenging questions you would like Mr. Wesley to solve in the upcoming videos, please email him the question. His email address is in the description. All right, let's do this. Here's Mr. Wesley.
Okay, welcome back to the next question. This question is about a regular polygon with n sides, and each side has a length of a. And they want you to show that the area of this polygon is given by this. So keep in mind that we don't know what n is. So if n is equal to 6, for example, it's a regular hexagon. If n is equal to 8, for example, it's a regular octagon, and so on. Now, it's a bit tricky to draw this because obviously we don't know what n is. However, there is something to keep in mind, and that is the vertices of a regular polygon can sit on the circumference of a circle. In other words, if you have a regular polygon, you can draw a circle around it such that it passes through each and every vertex. So for example, if it's a regular hexagon, it'll be like this, etc. Sorry, it doesn't look very regular, but there you go. So we are going to make use of that fact. Okay, so imagine we have a circle, and although we don't know n, we're just going to pretend that we can start drawing this polygon. And if you look at this triangle, somehow if we can work out the area of this triangle, we can work out the area of this regular polygon, because if you multiply the area of this triangle by n, that will give us the area of the polygon, because there are n polygons like this. Sorry, n triangles like this. Okay. So how do we calculate the area of this triangle? So this is the center, and this is radius, this is radius. So this becomes an isosceles triangle. Now let's see if we can find the area of this isosceles triangle. I'm just going to draw a neater version of this isosceles triangle. Let me scroll down a bit. Okay, so we have an isosceles triangle. The base is A. Now I'm going to draw a perpendicular from the top, and because it's an isosceles triangle, it's going to bisect the base. In other words, this is A over 2 and this is A over 2. And remember, the idea is to find the area of this triangle so that we can multiply that by n and calculate the area of the polygon. Now, do we know what this angle is? Well, this is half of whatever this angle is. Okay, now around this point we have 360 degrees. We have divided that into n equal parts. So this angle here is 360 divided by n. And this is half of that, because these two angles together that make 360 divided by n. So just that red part here is half of that, so 180 divided by n. Okay, so we are getting closer to finding the area of this triangle. Now, how do we find area of a triangle? Half base times height. Okay, base is a, so that's fine. So it's height that we do not know. So what we do know is this angle, and this is a right angle triangle. So for this angle, if we look at tan, so in other words, tan of 180 over n, that is opposite over adjacent, so a over 2 divided by h. So what we need to find is h. So if we make h the subject, the first step is to cross multiply. So we'll get h times tan 180 over n is a over 2. Therefore h, the height of the triangle, is a over 2 tan 180 over n. Okay. Now we can actually work out the area of the triangle. Why? Because we know the base. Base is a here. So half times base times height, we just worked out h. So a divided by 2 tan 180 over n. Now that is the area of one triangle. I'm going to rewrite that. So this is equal to, in the numerator we have a times a, so that's a squared. In the denominator we have 2, another 2, so that's 4 tan 180 divided by n. So what is this? This is area of one triangle. So what's the area of the polygon with n sides? It's n multiplied by this. So n a squared divided by 4 tan 180 divided by n as required. So let's go back and check. They have asked us to show that the area is na squared divided by 4 tan 180 over n, which is what we have shown now. Now take a look at the second part. In the second part, they're talking about a regular decagon, a polygon with 10 sides, a regular polygon with 10 sides. So in other words, n is equal to 10. Okay, so n is 10. Now and for this particular polygon, they say that each side is 8 centimeters. So your A is 8 centimeters. Your your N is 10. And let's plug all this into this and see what we get so far. So NA squared, so N is 10, A squared, so that's 8 squared, divided by 4 times tan 180 divided by 10. So that's 8 squared is 64, so times 10, 640 divided by 4 times. Now 180 divided by 10 is 18 degrees. But thankfully, they have given us an approximation for tan 18 degrees, and that is 0.32. So let's work this out and see if we can show that this is approximately 500 centimeters squared. The reason why they said approximately is that tan 18 degrees is not exactly 0.32. Okay, so to make our maths easy, I'm going to multiply both the numerator and the denominator by 100, so that this 0.32 will turn into a 32. So that's the idea. So I'm multiplying both the numerator and the denominator by 100. Okay, so we know that 32 is half of 64, so 64,000 divided by 32 is going to be 2,000. Divide that by 4. It is 500 centimeters squared as required. Okay, hope you like this question, and I'll see you again soon.
Great job today, everyone. Remember, the key is to take your time and practice the questions regularly. If you found this video helpful, please like, comment, and subscribe. It really motivates Mr. Wesley to create more videos. If you have any questions, feel free to email Mr. Wesley at WesleyMathsTutor@gmail.com. See you in the next one.